At this point, we have already had a discussion that if we have a polynomial that is completely factored, then we can apply the zero product property to quickly be able to determine the x-intercepts, which that word is interchangeable in a way with real zeros of that function. Now, earlier, towards the beginning of this video, of this series here, we had a discussion that between any two x-intercepts of a polynomial, for instance, between these two, the graph is either entirely above the x-axis or it is entirely below the x-axis. And now we're going to look at that in a little bit more detail. So here we have a polynomial function, and we have three tasks that we want to complete. The first thing we want to do is we want to find the x-intercepts and the y-intercepts. I'm going to start by finding the x-intercepts, which we find by setting the function equal to 0. To find x-intercepts, we are interested in knowing for what values of x is this function equal to 0. At this point, you may be able to just look at this and see that we're going to get -1 and +2 as our answers. But one thing you will learn about me is that I am very, very big on showing your work. I believe that your work should tell a story of what process you went through to get your answer. So I'm going to go ahead and set both of these factors equal to 0 and conclude that I get x is equal to -1 and x is equal to +2. So my two x-intercepts are the points -1, 0 and 2, 0. Now I will go on to find the y-intercept. We find the y-intercept by setting x equal to 0, plugging 0 into the function. That's not just true for polynomials, that's true for any function that you are trying to find the y-intercept of. So this leaves me with a +1 times a -2, which is a -2. And so now I know that the y-intercept of this function is the point 0, -2. Complete part B, I'm going to take our two x-intercepts of -1 and +2 and put them on a real number line for the x values. Notice that these two values break our number line up into three separate intervals. They give us the interval from -infinity to -1. Then they give us the interval in the middle from -1 to +2. And then finally, they give us the interval on the right side of +2 off to infinity. Now, on each of these intervals, we know that the graph is either entirely above or entirely below the x-axis. To figure out what's going on, I am going to choose a test value in each one of those intervals. It doesn't matter which test value we choose as long as it falls into that interval. So for numbers smaller than -1, I will choose -2. In between -1 and 2, I will choose 1 as my test value. I could have chosen 0 or -1/2 or 1.5, any number that's in that interval. And then finally, I'll choose 3. And now I am going to evaluate the function f at each one of those test values because I'm trying to determine is the function below the x-axis or above the x-axis at each one of these values. So here, when I plug -2 into the function, so when I take x and replace it with -2 in that function there, we get out a -4. When we plug 1 in, we get out a -4 as well. And when we plug 3 in, we get out a +16. So now that we know these values, we are able to say what the location of the graph is. Well, a negative value means that we are below the x-axis. Again, a negative value coming out for our test value when we plugged it in, again, means that we are below the x-axis. And then finally, when we plugged in 3, we got out a +16, which would indicate that we are above the x-axis. Notice that these test values, plugging them in, also gives us points that are on the graph, right? So now we definitely know that the point -2, -4 is on the graph, 1, -4 is on the graph, and the point 316 is on the graph. And so now we're able to use this information to graph the function. So we already knew that we had an x-intercept at the point -1, 0. and another x-intercept at the point 2, 0. I'm just going by ones on both of my axes, and a y-intercept at 0, -2. I'll go ahead and include the other points that we have. We have a point of -2, -4. I need to make my y-axis a little bit longer so we can get down to -4. So here's the point -2, -4. We also have the point 1, -4. So that would be there. And then finally, we have the point 316. I'm not going to go all the way up to 16. I'm just going to throw it right there. And now I'm going to connect these points to see what this entire graph looks like. I will point out that I know that the 0 of -1 has a multiplicity of 2. So when I hit the point -1, 0, I'm only expecting to touch the x-axis because of that even multiplicity. I'll go down, hit my y-intercept, hit this point here, turn. Here I am now approaching this x-intercept of 2, 0, which came from the factor of x minus 2 that had a multiplicity of 1, which is odd. So I'll be crossing here. We'll see more about this whole touch cross thing coming up soon within the next few minutes of these videos. Oh, in fact, we'll see it right now. So when we have a multiplicity that is even, what that means graphically is that the graph only touches the x-axis at that point. Alternatively, when we have an odd multiplicity, it means that the graph is crossing the x-axis at that point. Numerically, for even multiplicity zeros, it means that the sign of the function did not change when we crossed through that 0. So what do I mean? I mean that on the left side of this 0, the function was negative, and then again on the right side of this 0, the function was negative. But alternatively, if we had an odd multiplicity 0, notice here on the left side, the function was negative, but then on the right side, the function value is now positive. To our next try it, where you will be making a table kind of similar to this one, but you'll be adding in a third column where you're going to be telling me whether or not the graph is touching or crossing the x-axis. So for example, here I have a even multiplicity, which means that the graph would touch the x-axis at the point 0, 0. Right, so I'm getting 0, 0 going back to this 0 because I know the 0 corresponds to an x-intercept. When the multiplicity is odd, the graph will cross the x-axis at that corresponding x-intercept. So remember, 0, x-intercepts are points. Finally, 4 is even. An even multiplicity means that the graph will be touching the x-axis at the x-intercept of 1/3, 0. So that's what you'll be doing in your try it number 3.